Okay, let's jump straight into this incredible stack of material you've pulled together for us.
Yeah, there's some fascinating stuff in here.
Today we're doing a deep dive into a question that really twists the mind. Is the universe, at its deepest level, programmable?
hmm
Could we be living inside, I don't know, some kind of code or guided by a fundamental algorithm?
It's a question that pulls together theoretical physics, computer science, and honestly, some pretty deep philosophical water.
Right.
The sources you've provided, they lay out this fascinating case for looking at reality less like intricate clockwork.
And more like software.
Exactly, more like an incredibly complex software program.
Okay. So our mission here is to unpack the core ideas in your sources, find those surprising sort of nuggets of knowledge, and really try to get a handle on what it could mean if reality is some form of computation.
Sounds good.
Let's start with the concept many of these ideas seem to build on, digital physics.
Right. Digital physics. What's truly fascinating about it is the foundational idea that the universe doesn't just act like a computer.
Hmm.
It maybe is one at the most fundamental level. This view suggests that reality isn't necessarily smooth and continuous everywhere.
Meaning space and time might not flow seamlessly, not like a river, but choppy.
Exactly, they could be discrete, made
Yeah.
of tiny, indivisible units.
Oh, like pixels on a cosmic screen. Or
Yeah.
ticks of a clock.
Yeah, like that, or individual ticks of some fundamental clock. It shifts us away from the purely analog view of reality to a potentially digital one.
And this material suggests fundamental particles, things like electrons.
hmm
They are just little balls of matter, but maybe information.
Precisely. Think of a particle's state, its spin, its charge, whatever, as information. Maybe like the on or off or more complex states of a bit or a qubit.
Right.
And the entire evolution of the universe right from the beginning could be seen as the running, like the execution of this vast cosmic program.
Now, this isn't just, idle speculation, is it?
Yeah.
The sources mention actual physicists.
Oh, absolutely. People like Conrad Zuse, who was actually building computers way back, and Edward Fredkin, Stephen Wolfram.
Wait, Wolfram.
Yeah, serious thinkers who've proposed that maybe computation, this processing of information, is actually more fundamental than matter or energy itself.
That really flips things around.
It totally flips the usual perspective.
Yeah.
Instead of saying reality behaves computationally because of physical laws,
Uh-huh.
they suggest the physical laws might emerge from the underlying computations. Like, what if space-time itself is built from fundamental logical operations? Like incredibly tiny logic gates doing calculations.
Okay, that really changes how you picture, everything. And it feels like that line of thinking leads us pretty naturally into the weird world of quantum mechanics.
It does.
If reality is code, then maybe quantum physics isn't just describing the subatomic world. Maybe it's providing the actual rules it follows, the algorithm.
This material definitely makes a compelling case for that connection. I mean, quantum mechanics, with all its probabilities and discrete outcomes,
Yeah.
it has really strong parallels with computation.
Like superposition.
Exactly. Consider superposition.
Yeah.
A quantum particle can exist in multiple potential states at once,
Right.
which is very much like how a qubit in a quantum computer can represent 0, 1, or, a combination of both at the same time.
Until you look at it.
Yeah.
Until you measure it, and then boom, it collapses into just one definite state.
Yes.
The sources present that like a kind of calculation settling on an output.
Yeah, it's like a probabilistic calculation that runs, holding all these possibilities until an interaction or an observation forces it to resolve into a single result. And quantum entanglement, that really weird link between particles.
Where they affect each other instantly no matter how far apart.
That's the one. It feels remarkably like information being shared or correlated across some kind of computational network, almost outside of normal space.
So the way quantum computers operate, holding probabilities in these qubits until they're observed, it really mirrors how quantum particles behave.
The analogy is very, very strong. As people like David Deutsch have explored, maybe quantum physics isn't just the best description we have of reality.
Yeah.
Perhaps it is the low-level instruction set, the operating system, if you like, that reality is actually running on.
Okay, my head is officially spinning a bit.
Mm-hmm.
But if the universe is running on code, well, the next obvious, maybe slightly unsettling question is, who or what wrote it?
Ah, yes. The programmer question.
Your source material dives right into this, doesn't it?
It does, and it offers several possibilities for these potential programmers. One you've probably heard of is the simulation hypothesis.
Popularized by Nick Bostrom, right? That we're in a simulation run by some advanced civilization.
Exactly. Maybe even our own descendants running an ancestor simulation.
Like we're characters in their incredibly advanced video game.
A vastly more complex one, sure. But yeah, that's the gist. Another idea presented is Max Tegmark's mathematical universe hypothesis.
How's that different?
Well, he goes even further. He proposes that reality isn't just described by mathematics,
Okay.
but that it is mathematics. The fundamental mathematical structures themselves are reality. No programmer needed, in a sense.
Reality is math. Wow.
That's a big idea. And then there's another concept called pan-computationalism.
Pan-computationalism.
Yeah, the idea that reality is fundamentally computational. And maybe it computes itself recursively, like the universe is its own computer running its own program.
No external programmer needed there either then.
Potentially not. And this term quantum gods, that pops up in some of this material.
Yeah, what's that about? It sounds a bit out there.
It's not really about mythological deities, it's more a metaphor.
Yeah.
A way of talking about the source of the code, the fundamental logic, the underlying laws, or whatever intelligence or process guides these quantum operations. It's really asking about the origin point of the whole computation.
Got it. But let's be real for a second. How much of this is actual testable science versus just really compelling speculation?
That's a crucial point.
Because standard physics, as far as I know, doesn't have definitive proof we're in a simulation or that reality is code.
No, it doesn't. We absolutely don't have a smoking gun. That needs to be clear.
Right.
However, the material you've shared, it does point to some intriguing hints from physics. Clues, maybe, that suggest reality might not be the purely continuous analog thing we often assume.
Like what kind of clues?
Well, for instance, the Planck length?
The smallest possible length.
Theoretically, yes. If there is a minimum unit of space, a shortest possible distance, it implies space isn't infinitely divisible.
Ah, so it hints at a kind of graininess, a digital structure.
It could suggest that, yeah. A granular structure at the deepest level. And then there are theories like loop quantum gravity,
I've heard of that.
which pictures space-time itself as being woven from tiny discrete loops or networks.
Wait,
Again, it leans towards a quantized, maybe even computational view of space.
interesting. And the holographic principle is another one your sources mentioned that seems relevant here.
Oh, definitely. The idea that all the information describing a 3D volume, like, say, this room, could somehow be encoded on a 2D surface at its boundary, like a cosmic hologram.
So information is key.
It strongly suggests that information is absolutely central to the nature of reality, and that seemingly continuous things like space and time might actually emerge from how this fundamental information is organized and processed.
Maybe gravity.
Potentially. Even gravity, which we usually think of as the smooth curvature of space-time. Well, there are theories, like Eric Verlin's idea of emergent gravity,
Okay.
proposing that gravity itself might arise from differences in information density or flow at the quantum level. Now, again,
Proofs.
not proofs of a simulation, no. But they do make the idea that information and discreteness are fundamental feel a bit less outlandish, perhaps.
Yeah, less like pure sci-fi. Okay, this is where it gets truly fascinating for me, looking ahead. If the laws of nature are, in principle, programmable, what does that imply for the future? Maybe even for us.
Well, it opens up scenarios that sound, frankly, like deep science fiction, but are logically possible within this framework.
Like what?
Could a highly advanced future civilization actually figure out how to rewrite the laws of physics within their own reality?
Whoa, change the fundamental rules.
Change the constants, modify the forces, maybe. And could we or they create entire designer universes?
Custom-built realities.
Simulations so complex, so detailed, that any conscious beings arising within them would have absolutely no way of knowing they weren't in base reality.
That's a recursive nightmare, almost.
Yeah.
And your sources even touch on consciousness playing a role.
Some speculate, yes.
Oh.
Could consciousness itself interact with or influence the quantum code in some way? That's really pushing the boundary.
And with things like quantum computing, quantum AI, even quantum biology moving so fast.
Right.
The material suggests we might one day develop the tools not just to understand these ideas better, but potentially to actually manipulate reality at this fundamental level.
It's conceivable. Maybe generate new forms of matter with programmed properties or, yes, create those nested realities.
The thought that creation, making things, might shift from something we think of as, I don't know, divine or just natural,
Yeah.
to something that is, in principle, debuggable,
Hmm.
like software.
That's a profound implication raised by this material, isn't it? Debugging reality.
It certainly changes the perspective. Wow. Okay, so we've gone from thinking about reality as fundamental computation in digital physics,
Mm.
explored how quantum mechanics might be its operating system,
Right.
speculated about who or what the programmers could be, the quantum gods metaphor,
Mm-hmm.
and look at the intriguing hints from science and these really mind-bending future possibilities, all based on the sources you shared.
And this entire exploration, it leads to some really big questions for you, the listener, to maybe just ponder.
Yeah, questions like, is reality at its most fundamental level more like hardware, or is it more like software?
And are the quantum laws that govern everything we see and interact with, are they fundamentally discovered principles of nature? Or are they, in some sense, uploaded instructions?
And maybe the biggest one, if the universe really does operate like code, does that mean eventually someone could learn how to hack it?
Heady questions to carry with you as you navigate your day, which, might just be running on a very sophisticated platform itself.
Thank you so much for bringing these sources to our attention. They've sparked a truly deep, really provocative dive.
My pleasure. It's fascinating territory.
This material really compels us to consider that reality might not just be explainable by fundamental laws, but perhaps, at its very core, it is quite literally compiled.
It gives a whole new dimension to the idea of the universe just unfolding, doesn't it?
It really does. Until next time, keep questioning, stay curious, and maybe, just maybe, consider that somewhere out there, the coder is still watching.